For decades, enterprise software architecture has treated data as exhaust. Engineers build applications to serve users, treating the generated data merely as a byproduct, piped into centralized storage after the fact. When the system scales, that rigid industrial pipeline suddenly cracks under pressure. In traditional point-to-point architecture, data producers and consumers are tightly coupled. Everything wires directly to upstream databases. But when an engineer changes a single source schema, it triggers a cascading failure. Executive dashboards go dark, and machine learning models ingest corrupt inputs, degrading accuracy. When every consumer is hardwired to a volatile source, these breaks become a mathematical certainty. To stabilize the system, we must move away from direct manual dependencies toward a decoupled architecture. This transition is achieved through the data product, a curated, self-contained asset built using rigorous product management principles rather than one-off engineering scripts. By treating data as its own entity with a defined boundary, we can enforce quality, freshness, and accessibility, regardless of how underlying applications evolve. Simply dumping tables into a data lake does not create a data product. To qualify as a first-class asset, the dataset must adhere to 8 specific architectural characteristics. First, it must be discoverable, cataloged and fully searchable via a centralized registry. Second, it must be addressable, accessed via a standardized, persistent endpoint. Third, it has to be understandable, requiring clear documentation and schema specifications. Fourth, it must be trustworthy, bound by explicit service-level agreements defining expected latency and error rates. Operationally, the product must be secure, governed by role-based access control. It must also be interoperable, structured in standard formats for querying without custom translations. Seventh, it is self-contained, bundling the raw dataset and transformation logic into a single cohesive unit. Finally, it must be inherently valuable, providing standalone operational insight or predictive capacity. When these 8 attributes are enforced, enterprise data moves from an unpredictable liability to a highly reliable, universally accessible asset. Constructing a system with these attributes requires a 7-phase lifecycle. The engineering work begins well before the first data pipeline is coded. Phase 1 is strategy and ideation. Here, data product managers collaborate with business stakeholders to define the problem, identify the target consumers, and establish baseline return on investment metrics. Phase 2 is design. It inserts a formal data contract between source and consumer, hard-coding schema formats. This creates physical decoupling. If an upstream application violates the agreement, data is caught at the barrier, protecting downstream consumers. With the rules established, Phase 3 covers ingestion and storage. Data engineers move the batch or streaming source data into a scalable storage layer. Here, data is saved in open table formats. Tools like Delta Lake act as the storage mechanism, bringing transactional reliability to raw file storage. Delta Lake executes ACID transactions by locking the block, applying updates in full, and unlocking, preventing corrupted files. It also uses a timeline log, allowing engineers to revert data to an exact historical state if errors are detected. By enforcing schemas at the point of ingestion, Delta Lake ensures that downstream consumers are never exposed to records that don't match the agreed-upon contract. Anchoring formal data contracts to ACID-compliant storage creates a stable environment where the data state is always verifiable and predictable. Phase 4 handles transformation, modeling, and science. This is where the raw storage is refined into business entities. This medallion architecture structures data into 3 tiers. Bronze preserves an exact replica of raw inputs. Silver cleans and unifies them into standardized records. Finally, gold aggregates records into high-value business entities ready for immediate use. Executing this architecture over massive datasets or real-time streams requires high-performance processing. Platforms like Databricks provide the computational power needed for this enterprise-scale engineering. To manage these transformations, teams use tools like dbt and SQL to organize pipelines into modular, version-controlled models with built-in testing. In this phase, data engineers build the pipelines to move data from bronze to gold, while data scientists use the refined gold features to build and train machine learning models. Phase 4 functions as the ultimate factory floor, continuously converting raw storage potential into finished, highly deployable business intelligence. Once the product is refined, Phase 5 handles publishing and delivery. the finished asset must be exposed through a reliable consumption interface. Even after delivery, the product enters Phase 6, Operations, Quality, and Observability. This discipline, known as Data Ops, uses automated testing and distribution profiling to ensure the product continues to meet its SLA. It flags anomalies like schema drift or pipeline delays before they impact the end user. The lifecycle concludes with Phase 7, Evolution and Retirement. Engineers must version their schema releases, allowing consumers to migrate from version 1 to version 2 over time. When a data product no longer serves a business need, it is formally retired to prevent the accumulation of stale assets. Continuous data ops and strict version control are the mechanisms that keep a data product consistently reliable throughout its operational life. All these phases result in the self-contained data product, wrapping the lifecycle into a single deployable unit. Inside this boundary, it holds the dataset and the exact transformation logic required to interpret it, presented through a stable interface. This modularity enables a decentralized data mesh. Different domain teams can manage their own products, which are then shared across the organization. Built to standard formats, they query each other securely, creating a synchronized network rather than isolated silos. This architectural framework is entirely vendor agnostic. Tools like Delta Lake, Databricks, and MotherDuck are the powerful levers used to achieve specific scale and speed, but the underlying intent of the data product remains the exact same. By treating data as a first-class product, governed by strict contracts and continuous operations, organizations can finally move past the cycle of manual pipeline repair and build a scalable ecosystem of truly trusted assets.